Hey friends, everyone is building AI agent, but most are doing it wrong. In this video, I'll show you 6 proven AI workflow patterns that will help you build a smarter and more robust system, whether you're using N8N or code. And this isn't just my opinion, it's based on a very insightful post by Anthropic called Building Effective Agents. And I've adapted it for real-world builds. So these patterns are the foundation of every intelligent, scalable system, and understanding them will help you build faster with fewer bugs and better results. Let's start by mapping out the 6 core patterns. First, we have prompt chaining. Here, we are going to break big tasks into reliable steps. The second one is routing. And here we are going to send inputs to the right handler. The third one is parallelization. Here we are going to work faster or smarter through multiple angles. The fourth one is the orchestrator. And in this one, we are going to dynamically assign tasks based on the input. The fifth one is the evaluator-optimizer, and here we are going to improve quality through feedback loops. This one is very interesting. And the last one is the agent, where AI has full autonomy, but of course it has a higher risk. And of course, you'll be able to download all the workflows I show in this video for free, so you can reuse them or adapt them to your own projects. And you also get this document that summarizes all the patterns, and you can keep it as a reference. Anytime you need to build something, just come back to it and choose the right pattern. And by the way, I've built a tiny app that helps you choose the right pattern based on your use case. It's got a front end made with Lovable, and it maps your input directly to the best fit pattern. It's only available inside the AI Alchemist community, so if you want access, make sure to check the link below and join us. Now let's walk through each pattern, when to use it, what it looks like, and how to build it. I'm Alexandra Spalato, a full-stack developer, AI strategist, and founder of AI Alchemist community. I help people and businesses build real AI tools fast, using clear workflows with or without code. If you want to build smarter, you're in the right place. First one, the prompt chaining workflow pattern. So here we have multiple LLM calls that work in seconds, and each one is building upon the previous one. You can use the same model or different models for each call. And when to use this is for tasks that can be clearly broken into sequential steps, and we're going to trade latency for higher accuracy, because of course you make several calls, so it will be longer, but you will have a better accuracy, which is what we want. So the benefits are we have a better quality thanks to focus task. It's going to be easier to debug at each step, and it will be modular and more maintainable. So this is good for things like content generation, to plan the final output, to process data pipelines, to make a multi-step analysis. And so it's much better than giving everything to one LLM. Here we are breaking the responsibility, and each step build upon the previous one. So let's see an example that I have especially created for this video. Here is an example where we have 3 LLM calls to create a market strategy for an application that we want to launch. So the first one is going to analyze the market. The second one is going to prioritize features, make a roadmap. And the third one is going to make a go-to-market strategy. So I have created this prompt. I want to create a mobile app that helps remote workers find and book quiet workspace in coffee shop, libraries, and co-working spaces in their city. That would be very needed in Madrid, which is super noisy. The app would show real-time noise levels, Wi-Fi quality, and available seating. So I have already run it for you, and this is the result. So a super detailed report. Okay, so let's examine each LLM call. So here I have used the same model for the three LLM calls, but of course we could use a different one for each one. And I'm using OpenRouter, which allow me to test different models. So you can test until you find the sweet spot, and you can assign different models to each call to see what works better. So the first one is receiving the chat input and is going to research the market. Of course, in real world, I will certainly attach a tool to search the web. Okay. Then the second one, the feature prioritization specialist, LLM, sorry, is going to take the result from the market research and the original business idea and create a prioritized feature list, including must-have core, MVP, etc. And finally, the last one, the go-to-market strategy creator LLM, is going to take all that, so the market research, the feature roadmap, and the original business idea, and develop a go-to-market strategy. Okay, so this is a very good one, very simple one that can be used in many cases. Second one, the routing workflow pattern. So here we have an LLM call that is going to classify the input, and from there is going to direct it to specialized AI handlers based on the category. So when to use it? When we have distinct input categories that benefit for specialized handling with accurate classification possible. What are the benefits? It will provide specialized responses for each category. There will not be interferences between different input types, and it will optimize the cost. So the route is simple, so we can have fast models, and if the route is complex, we can have more capable models. So this is good for example, customer service queries, content classification, model optimization strategy, and everything we can think about that can be classified and given to different models. And here is a real-world example for a customer support. For example, so here we have a chat, and we have first a customer query classifier that is going to route it to or technical support or billing support or general inquiry support. Let's test it with this customer query. My credit card was charged twice this month, so we launch it, so it goes to the classifier. Here in the classifier, we give three categories: technical support, billing, and general inquiry. And here we are using a special node, which is, I have renamed it, but it's this one. It's the text classifier node that works very well for that. And for this, you need to give the three categories with their description, and the model is going to route it to the right category. So in our case, it's the billing support LLM, and here is the answer. Okay. So here I have attached it again to the same model, and each demand is not more complex than another here, but in real world cases, of course, you can attach different model depending on the complexity of the category and the demand. In real world also, for something like that, we would attach memory. We will make a RAG, for example, to get all the information about the company to better answer the question. But what I wanted to show is how we route the different categories to different LLMs to answer correctly. The parallelization workflow pattern. So here we have multiple AIs or multiple LLM calls that work simultaneously and then aggregate the results. So we pass this input to these three LLM calls. And there is two types. Sectioning, so here we are going to analyze different aspects of the same input, and voting, where we are going to give the same task to multiple AI models for consensus. And then we pass that to the aggregator. When to use it? When you want to optimize speed, or when you need multiple perspectives to improve quality. Well, in N8N, you are not going to optimize speed. It will be slow because it's going to run to each branch one after another. But if you work in code, it's totally possible, or perhaps in N8N using webhooks and not doing in one workflow. What are the benefits? So faster execution when it applies, higher confidence to multiple perspectives, better quality when each AI focuses on specific aspects, and it's good for content evaluation, code review with voting, creating prompts, research for multiple angles, etc. So now let's dive into real examples. Here is an example for the sectioning type, and we are going to use it to evaluate the accuracy, readability, and tone of content. So here as example, I have just taken the Wikipedia definition of AI, and this is the result. Okay, so accurate and well-structured, use of relevant example, recognition, historical, areas of improvement, score, etc. So let's see how it runs to the workflow. So here we have the input, and we pass it first for the accuracy elevator. So here we pass our input to evaluate the factual accuracy of the following content. Of course, again, in real world, I will connect that to a web search tool. Then give its result here. And in parallel, so again, here in N8N is going to run the branches one after another, okay? But if we send that to a webhook, for example, then it will be possible, but I think to run in parallel, really, code will be more suitable. Then we have a readability evaluator that is going to evaluate the readability from the input. And finally, we have a tone evaluator that will evaluate the tone and style of the content. Then here we are going to use a merge node and to append the three results. Here I had to use a code node to rename it as accuracy, readability, and tone. And then we have our final aggregator LLM, which is going to synthesize the following evaluation result into a comprehensive content assessment. And so we give it the result from our three LLM calls. Okay, so this was the sectioning one. Now let's see an example for the voting structure. Here for the voting case, I'm using a workflow that I have created for another video that you can see here, which is a mixture of agent, and it's a perfect example of parallelization with the voting pattern. So here I want to create the perfect prompt, and I'm going to pass it to 4 different models. So here we really need to pass it to different models, but with the same prompt. So in each node, I have exactly the same prompt, and I pass my chat input, but each time I have a different model. Okay, and then in this case, I'm aggregating them 2 by 2 and then merge everything. And then we have again at the end an aggregator that is going to synthesize everything, the 4 outputs. Okay, so, and here it's still searching. So I ask it to write me a prompt to create a blog post SEO optimized. And here is the result. So we have a super detailed prompt. Okay, so this is a really good one, and I really recommend that you watch this video if you want to deep dive and use this for yourself. The Orchestrator workers workflow pattern. So here we have an input and a central AI, the Orchestrator, that analyzes input and create tasks that it will dynamically assign to different worker AI, so to different LLM calls, and then we have a synthesizer and then the output. So when to use it? When we have complex tasks where you can't predict subtasks in advance. So the subtasks depend on the specific input. So we are closer to the agent here, but it's still a workflow. But the frontier begins to be blurry. What are the key benefits? Dynamic adaptation to the input requirements. We have an intelligent task delegation, and it's flexible. We have a flexible scaling based on complexity. So it's good for marketing campaigns, complex project management, adaptive research tasks. And what is the difference with parallelization? Here, the subtasks are determined dynamically and not predefined. So let's dive in an example. It will be much clearer. In this example, we are using the Orchestrator to assign tasks to a social media specialist, to a content marketing specialist, and to an email marketing specialist. And so I have used this entry. We're launching a premium skincare line targeting professional women aged between 28 and 45. We have 3 months to build awareness with 75,000 marketing budget, etc. And this is the result. So all the campaign with social media, etc. So how it works? Here, our Orchestrator. Okay, you are a strategic marketing orchestrator. Analyze the following business goal and dynamically determine which specialized marketing team should be involved. So based on this goal, determine which of these specialist teams are needed and what specific tasks they should include. And so we have the available specialist, and for each specialist, we need to create a detailed task. So AI is creating the task. That's dynamic. That's not predefined by us. So this is the output. Okay, so now we have the task for the social media, the task for the content marketing, and the task for the email marketing specialist. From there, we pass to each one his own task. So here is the social media that receive the social media task. Okay, and we have also the priority level. And then we have the content marketing specialist. Okay, and here we can see all the output. Well, same thing for the email marketing specialist. Then we have here a merge node, and we aggregate the 3 results. Then we pass this to the aggregator LLM here. And you are a marketing strategy synthesizer. Combine the following specialist recommendation into a cohesive, integrated marketing campaign. And that's it. And we have this result. So I really like this this pattern because it's close to an agent in the fact that the orchestrator is creating the task. AI is creating the task to pass them to other specialists, but we still have control. We still have guardrails. So this is a key thing to remember with AI. Keep control as much as you can and balance it with the needed flexibility. So here we need flexibility to create different tasks, but the workflow make it very controlled. The evaluator-optimizer workflow pattern. So here we have an AI that generates content and another one that evaluates the quality and provides feedback in a loop. So when to use it? When we have a clear quality criteria that exist and an iterative improvement that has measurable value. What are the key benefits? Built-in quality control, measurable improvement through iteration, and a self-correcting system. So it's good for creative writing, technical documentation, code optimization, content requiring refinement, etc. And what are the requirements? We need a clear evaluation criteria, an actionable feedback, and an improvement potential. Let's see an example. So here I'm going to enter these inputs, write a compelling email subject line and opening paragraph for a marketing email promoting a new online course about personal finance for millennials. The course teaches people how to save for their first home while paying off student loans, etc. So I run it. And so the content generator here. Okay, he has already written. You are a creative writing specialist. Your task is to create engaging, compelling content based on the following request. Then we have another. So, okay, this one has passed the test immediately. We will see other examples. So here, in this edit field, I extract the content generated. And here I put a max number of iteration because we don't want this to run in an infinite loop, okay? And here I have a try catch because I have this counter, or it's 1 for the first one, or then we pass the increment counter if it has already run, because it's a node that is run after that. So it was needing a try catch, otherwise it was breaking. Okay, so after that we have the content evaluator, and here I have put a better model. I have put GPT-4.1 and the other one GPT-4.1 mini. You are an expert content evaluator and editor. Your role is to assess the quality of creative content and provide constructive feedback for improvement. So you evaluate this content, you have the original request, and then assess the content based on this criteria: engagement, clarity, structure, creativity, tone, and it returns a JSON. Okay, so here is the JSON. So here I have required specific output format, and I had structured output parser. So here we have a score of 8, and as I said, that only accept true if the content scores 8 or higher overall. For anything below 9, well, okay, that was a mistake, it's 8, provide specific actionable feedback for improvement. But yes, I put it for 8, and I will show you why I tested with 9 too. So from there, as we have 8 yield and is accepted, we have a if node. So if it's accepted, we deliver the output directly, and if not, we return there. But we have this increment counter, and so here we add +1. Okay, so here it passed immediately, but for example, in the execution, so I put the criteria to 9, and it was never passing. And let's see what I did in my executions. I copy this to the editor. So you see here, I put the maximum to 2 iterations. And here, yes, here it was to 9, but the score was 8. So it was not passing. And it passed 2 times. And after that, on the second one, as the number was 2, then even if he was not passing the criteria to be above 9, then it was passing on the true branch, because here I have or the JSON output accept is true, or this is greater or equal to the max iteration. Okay, and so this is to avoid infinite loops. And here is a perfect case where you should try models. So here I put one model and to put a strong model for the evaluator. So I think this pattern is very, very interesting and useful. And finally, the agent workflow pattern. So what is an agent exactly? It's an autonomous AI that operates independently with tools, making decisions about the next step and stopping conditions. When to use them? When we have an open-ended problem where the steps can be predetermined. So it requires trust in the AI decision making. So what are the key benefits? It has true autonomy with minimal human intervention. It gives intelligent planning and tool usage, and it can handle complex and unpredictable tasks. What is best for research tasks, coding projects, system troubleshooting, strategic analysis, but it has higher cost, potential for compounding errors, and it requires robust guard rates, and it can be also slower. So let's see an example of agent, very simple. This is the typical personal assistant where you have the agent and you have a memory, a chat, and we have an email tool and a calendar tool. So you can ask it, oh, please check my emails. And then if there is a meeting to take, check my calendar and set up a meeting, and then check my task. So here, the input is very unpredictable because we are talking to AI and asking different tasks that can compound one upon the other. So this is not built in reality, but there is plenty of examples of agents. In conclusion, these building blocks aren't prescriptive. They're common patterns that developers can shape and combine to fit different use cases. The key to success, as with any LLM feature, is measuring performance and iterating on implementation. So remember, add complexity only when it demonstrably improves the outcomes. So success in the LLM space isn't about building the most sophisticated system. It's about building the right system for your needs. So start with simple prompts, then optimize them with comprehensive evaluation, and add multi-step agentic systems only when simple solutions fall short. So when implementing agents and complex workflows, follow these three principles. Maintain simplicity, so keep your design as simple as possible. Prioritize transparency, so explicitly show planning and decision steps, and carefully interface the design. So thoroughly document and test your tools and connection. And of course, if you join my community, you will have these little apps that I'm building to choose the best patterns. In this video, we've covered 6 AI workflow patterns that help you build smarter, not harder. From chaining and routing to orchestration and optimization, these are the mental models that keep your builds clean and scalable. So if you want to build tools that actually deliver, start with the right structure. Don't jump into agents until you've mastered the rest. And if you're into this kind of thing, build these smarter AI apps with clear workflows, you might like the community I run. We build full stack apps together using these exact patterns. And inside, you will also find the little pattern picker app I mentioned earlier. It's a helpful tool to figure out which architecture fits best for what you're building. And if you're building a product or want to integrate AI into your business, book a free strategy call with me. I'll help you apply the right patterns to your use case and avoid common pitfalls. The link is in the description. Lastly, if this video helped you out, please give it a thumbs up, subscribe to the channel, and drop a comment if you have questions or ideas for future videos. Thanks for watching. See you in the next one. Bye.